Hi, everybody. Good afternoon. It's Friday afternoon, and we've got a wonderful brown bag with Morgan Sanders, who's going to talk about the foundations of Highland. I'm going to let her have the floor with this brief introduction. So everybody say hello to Morgan.
Hello, Morgan.
Well, hello, everyone. Thank you for coming today. And I'm really excited to kind of share with y'all about my senior research and my summer. So this summer, we got an incubator grant and we were able to do some more research at Highland, building on the work of the spring 2022 field methods class. So a little bit of history about Highland. So Highland is referred to as James Monroe's Highland, the fifth US president. Monroe purchased the land at the urging and pleading of his close friend, Thomas Jefferson. And he initially purchased 1,000 acres in 1783 from the Carter family. Construction began on Monroe's home in 1797. Monroe's moved in to the property at 1799. And at its height of the Highland farm, the property was approximately 3,500 acres. And the Monroe family lived there sporadically until 1826 when Monroe sold the property. And then it passed down through several private landowners. And then in 1974, J. Johns willed the property to William and Mary upon his death. All right, so the geology of Highland. Highland sits on the eastern limb of the Blue Ridge anticlinorium. Right here, I'm pointing, it's just south of Charlottesville and Monticello. And Highland sits on the Catoctin formation. So around 600 million years ago, basaltic lava flows flooded the Earth's surface. And then a little bit later, the basalt underwent deformation and metamorphism, which produced distinctive foliation in the rock. So here is my study site of Highland. You can see this elevation profile here on the bottom. There's not a lot of change. It's a very, very flat landscape, and there's not a lot of relief there. Oops. All right, so the Catoctin formation at Highland, we see three types of rocks. The first rock is greenstone, which is a metamorphic rock, and it's slightly magnetic. And this is a sample of it here. If y'all would like to pass it around. The minerals that give greenstone its greenish gray color are chlorite, a little bit of epidote, and actinolite. Our second rock is meta-arkose, which is a metamorphosed arkose. And it has a clastic texture and with lots of feldspar and quartz. And the last rock at Highland that we've logged is in this picture here. It's a meta-siltstone, which is a metamorphosed siltstone. It has distinct foliation. And those are kind of these linear lines here that you see kind of trending east-west, and those are also contain a lot of chlorite. Yeah, so how did I get kind of on this project? So I'm graduating in December. I'm double majoring in history and geology. And when it came time to choose senior research, I really wanted a way to incorporate history and geology into my project. And so Chuck mentioned this project and I was like, oh, I'd love to do this because it is so interdisciplinary. And this is a picture of my first visit to Highland in 2007. And you can actually see some of the changes that have happened over the landscape just from 2007 to this picture in spring 2022. So what were the goals of my research? My first goal was to produce a geologic map of the property. So that's what I'm going to talk about first. So how does producing a geologic map work? Well, in our case, I looked at the property on Google Earth, and then we would look for okay, this is another view. This is the DEM LiDAR data, kind of showing the topographic of the landscape. So we would look for outcrops. So this is zooming in, and you can see some outcrops popping up on the landscape here, here, here. So we were really curious about this outcrop. So then we would go there actually. And this is what the outcrop looked like. And so you can see that this is a greenstone. It's very foliated here. You can see it here. And this piece is actually fallen on top of this other piece. And the first thing we would do when we get to an outcrop is we would locate ourselves on the UTM grid, and we'd also mark our location on the GPS. I would note things such as the rock type and write a short description of it, its minerals. And then we would do structure measurements using a Brunton compass, and we would note things such as foliation, fractures, veins, and then we would collect samples. So this is an example of my field book from Field Methods. And there's our location, our time that we got there, where we are, and then the rock and several notes about it there. So this is a Google Earth image, and it notes all of my sample sites where we went and kind of had stations around the property. And then I added this data to the data collected by Field Methods. And then I mapped all of them on this contour map, noting things such as the name of the station, the type of rock. And so this is one view of the property, and then another image. And this is all structure measurements, which tells us things such as if there's any folds on the property that have happened over time. So then most recently, I added polygons to my map. And so this is our first showing of this map. You can see it's really starting to take shape. So you have a lot of greenstone on the property. Then we also have our metasilt stones, and then our Arcos sandstones. And then these yellow lines are all of the alluvium on the property along the different creeks. This is Massey Creek right here on the south side. Up here on the northwest area, this is actually a debris flow deposit right here, which is really interesting on the landscape. Yeah, so this is my map. And then this green line is marking the Highland property. My second goal was to create a field guide for the property with field stops and explanations. And the goal of this field guide is to connect the modern landscape with geologic time. And so the field guide is really for Highland and for visitors of Highland to use so that they can learn about the geology of the landscape. Highland has a really rich history. It's currently a historic site and also a working farm. So it's really interesting to analyze the property from different perspectives. You can talk about the slaves that lived at Highland, what they did, their stories. You can also look at the landscape change. We have images from the 30s that show some features that now don't exist, or features that didn't exist in the 30s and now exist today. And so my goal with this field guide is to make it accessible for people so people can view it online. They don't have to go to Highland to see it. And they also don't have to walk the entire property to learn about the landscape. So these are kind of my stops on the field guide. I have about six stops, and they cover a range of things, including the water, the watersheds. There's a huge gully system in one of the pastures that's really interesting, soils, their conservation efforts, and also about the rocks. And we're also doing this because Highland has several signs about the geology, but not all the information is correct. As you can see here, they have the lava flows occurring between 320 and 350 million years ago, which is not when they occurred. So these are the sites and stops that I've chosen in my field guide. Most of them are centralized around the Highland home and museum area, and some of them are accessible through the trails. But again, you can also just view them from your living room or your couch. My last goal was the foundation stone investigation. And this is really the cool stuff to me. So a little bit of background information. So Highland realized in 2016, after doing some remote sensing on the property, that the house that they had been saying was Monroe's house was not actually Monroe's house. It didn't date to the proper time period. So they began digging archaeological test pits, and then they realized there was a foundation kind of underneath the house, the structure that is there today, but is a matter of inches below the surface, which is really interesting. And so this is kind of a figure from their archaeological paper. Here's the structure. The Massey house is this yellow building here, and that is what you can see today. And here's a test pit on the eastern side of it. So this is the Monroe house foundation that is fairly well preserved since the house did burn down in a fire. And here you can see the base of a chimney made of brick. So most of the foundation is made of stone. So that's kind of what we were interested in investigating, you know, what type of stone is it? Where did the stone come from? And here's another view. And you can see here it is the Massey edition, which is what we have today, the yellow house. And then this is part of the foundation of the original home. And so Chuck and I, one day in the summer, worked with Dr. Sarah Bon Harper, who's the executive director at Highland, and we conducted a small archaeological dig right here, about approximately in this area that I'm pointing to. And here's another view. As you can see, we didn't have to dig very far to actually see the foundation stone. It's covered under the reddish soil at Highland here. There's a piece, and then this is the piece that we actually took out of the ground. So here's the foundation stone. I have it here with me today, a piece of it. You can tell that it definitely has a weathering rind on it from being in the ground. And it looks very similar to the Arcos that I passed around earlier. So then we were like, did it come from the property? Because that would be super interesting if it did. So we cut the stone, and then I polished a piece of it. And this is also another piece of the Arcos polish that I passed around using the rock saw and then the polisher. So then we started looking at the DEM data, and we're like, is there a potential quarry site on the property? And so here we have the North Pasture. There's the huge gully system in the North Pasture. And so the site that we were looking at is kind of a little bit north of it, and really close to the parking lot. You can see the parking lot outlined here. And so this is another image of the possible quarry site. You can see that there's kind of an impression here where it looks like something was cut out and taken out of the earth. So then we went there in person, and we were like, what does the site look like? So this is what the quarry site, potential quarry site looks like. You can see there's a lot of boulders, random sized cobbles of rock in this area. It's a very nasty forested area. In the summer, it was not very easy to get to. It was definitely easier to get to in the spring. And then you can see here on the right, we have another interesting shaped rock on the ground. And there were these really big rectangular blocks also in the quarry site. So this is another image of another block here. And so one thing we were like, well, if this rock was quarried, it would have been quarried by hand by enslaved people. And it would have been carved with a chisel and like a mallet. So we were like, there should be tool marks on these rocks. So we looked as best we could. And, you know, you could make arguments here. You can see this could potentially be a misstrike from a chisel. If you're going to, if you're chiseling the rock, you could slip. And so you could argue that this is a misstrike, and also some along here in the shadows. But you can see it is very linear, and part of that could just be due to the rock itself. So this was the sample that we collected from the quarry site. Again, it has a really interesting shape to it. And part of that could just be from quartz veins and where the rock breaks naturally. But this is the sample we got from the quarry site, potential quarry site. And then after we polished it, we sent it off to get thin sections. So then I got to use a little bit of petrology and just analyze the thin sections. So this is the first thin section that we looked at. As you can see, it has a lot of quartz, a lot of feldspars, and it's got some very angular grains, and definitely has a clastic texture. And this is the second thin section picture. Again, a lot of quartz, a lot of feldspars. They look fairly identical to each other. So I'm going to go ahead and pass around the foundation stone. So the thin sections really do kind of support our argument in our case for the fact that we could potentially make the argument that the foundation stone was taken from the Highland property. It would make sense that the stone would have been taken from the property. It would have been easier to transport at the time that Monroe built this house. He didn't have a lot of money at that time yet. He was slowly accumulating popularity and land around Virginia. So it would make sense that the foundation stone would have been taken from the property as a way to kind of save some money in the building of his home. So you can see these pictures, they are practically identical, which is really exciting in our investigation. Yeah, so thank you all for listening. Definitely further research can be done on the foundation stone, and a more like formal work should be done. I think at Highland, there's a lot of potential for learning on the property. So I want to thank Chuck Bailey, my advisor, the William Mary Structural Geology and Tectonics Research Group for all of your help over the summer. We have some members here in this picture. Also, we have the field methods class when we conducted a small survey of one of the outcrops there. And also Dr. Von Harper for all of her help advising about the land and kind of historical facts along the way. So thank you.
That's very interesting. Questions?
Yes.
So, Morgan, you missed the field trip this week. And one of the questions that got asked repeatedly on the field trip is, what is the depositional environment of X or Y? And so my question to you is, what do you infer or interpret the depositional environment of these arkoses, which are interlayered with the metabasalts to be?
Right. So Chuck just asked, what do I interpret the depositional environment of the arkose and kind of metasandstones to be? And that's a very complicated question. You could argue that they are rift deposits, rift sediments. Also, if you factor in the opening of the Iapetus Ocean, you could make that argument that that's when those sediments were deposited. I believe that they were definitely deposited in a more marine environment. But I would need to do a little bit more research into that before I could give a definite answer. But those are my thoughts initially. Yes.
Well, I'll follow that up then. I'm not saying it's a marine deposit. I like to, be unequivocal about that. But what I've always found puzzling about these is that, feldspar quartz and a few other little bits in here, we never seem to see any class of, metabasalt.
Right.
And what is that telling us? I mean, because they're interlayered with the metabasalt.
Yeah. So I think, if there was also some erosion happening at some uplands, that were predominantly composed of granites, to me, if that was eroded and then brought and deposited in that area. I think that's another explanation that could explain why there's not a lot of, greenstone class, basaltic class in these sediments.
Okay, and I mean, I think that you could maybe make the argument, but I'm not a sedentologist or a basin analyst, that the, maybe these are subaqueous deposits. And so the basalt were not in this area exposed to actually be eroded, that they were actually extruded subaqueously, and that your source area is not been covered by basalt.
I'm gonna stop sharing so I can see other places.
Yes. Great. Yes, Terry.
Actually, for Allison Dorothy, well said, great job, Morgan. What was the most surprising part of your research?
Well, Allison just asked, well, those of you on Zoom can probably see it in the chat, but what was the most surprising part of my research? I would say I was surprised at how similar the thin sections actually look to each other. I knew based on looking at the rocks themselves that they looked fairly similar, but actually, looking at them under the microscope, I was kind of blown away by how similar they actually look to each other. So I think that would be the most surprising part of my research. Yes, Terry.
Okay, this is Terry actually speaking this time. So we're talking about subaqueous basalt and stuff. How do we know that they're subaqueous and not not?
Well, there are, we made the argument and we asked questions in field methods about pillows in the greenstone. And pillow basalt is something that does form underwater. So we saw some of those on the property and, we debated back and forth about whether or not they were pillows, but there are some pillows just north of the property, Highland property, at an outcrop in the Rivanna River.
Thank you.
You're welcome. Yes, Linda.
My question is, you said there's a potential for future work on this property. How would
Yes.
you like to extend your research? What future work could other geology majors do on the property?
Right. I think more research could be done at the debris flow and the debris flow scar. I think more research could be done on dating that debris flow, what caused it. I also think there could be more work done on the gully system and, potentially producing a more detailed map of the gully system since it is so vast and, aerial images in the 1930s didn't show any gullies. So I think that could also, work could be done there to kind of investigate why. And then also Highland has introduced several efforts to kind of minimize the gully system. Cows are no longer able to access that area. So I think that could be a very interesting research topic as well. All right, any more questions? Thank you all again for listening. Appreciate it very much. So thank you.